Alright, welcome. In this video I'm going to be recording solutions for BC Homework 3.2, and so let's just get to it. We're going to start with the problems that are like, hey, here's an algebraically defined function, determine if we've got, where are all the critical points, which are maximum, minimum, or neither, give a reason for your answer, justify your answer, you know, there's always some sort of disclaimer. Alright, so the first one is going to be x to the 4 minus 4/3 x to the third. Okay, so the critical points are the places where the derivative is 0 or undefined, so I'm going to take the derivative and find out where it's equal to 0. If I want to find where it's 0, it's polynomial, so it's never going to be undefined. If I want to find where it's equal to 0, I need to factor it, so I'm going to say that's 4x to the 2 times x minus 1. Okay, so my critical points are x equals 0 from the 4x squared equaling 0, or x equals 1 from x minus 1 equaling 0. Okay. Now, I think because this is a pretty easy one, I'm going to just draw a picture of it. But you could definitely, you know, choose a test point and determine if it's positive or negative based on that. I'm going to say this is a third-degree polynomial with a positive leading coefficient, so it's going to come from below. It's going to bounce at 0, and then it's going to pass through confidently at 1, because it's just 1 power here, 2 powers there. And so, as a result, I'm going to see no sign change in y prime. I don't know what we called it. Originally, it was f. Okay. In y prime, we saw no sign change at 0, so I would say x equals 0 is neither. Y prime doesn't change signs. Okay, x equals 1 is going to be the location of a relative minimum because the graph of y prime goes from negative to positive. The derivative goes from negative to positive. So, of a minimum, y prime goes from negative to positive. All right, and all right, the second one, x to the 4 minus 8x to the 2. I can always turn that upside down. Yeah, fine. So y equals x to the 4 minus 8x to the 2. If I want the critical points, it's the zeros or the places where the derivative is undefined. So y prime is 4x to the 3 minus 16x to the 2. So that's looking like, I don't see what the difference is going to be in this one and the previous one, but you know, whatever, we can deal with that, I guess. No, it was 8x to the 2, so that's 16x. Okay, I was going to say there was not enough difference in that for me to assign that as a separate problem. And I did write this homework, so I like to think I'm a little smarter than that. Okay, so I'm going to factor out a 4 and an x. Yeah, now we're back in business. So that's going to be times x squared minus 4. So that's 4 times x plus 2 and x minus 2. Okay, and that's going to be equal to 0 when x is equal to 0. This will be equal to 0 when x is negative 2. And this will be equal to 0 when x is positive 2. Maybe just for the sake of, like, I'm pretty sure if you knew how to sketch the graph of the last one, you'll know how to sketch the graph of this one. But maybe just for the sake of, like, showing you on this video, I'm going to do test points on the number line. So I'm going to choose x equals something more negative than negative 2, like, I don't know, negative 100. Well, that'll be 4 times a negative times a negative times a negative. If it's really negative, like more negative than negative 2, all these things will be negative. So it'll be negative, negative, negative. That will be negative. Okay, between negative 2 and 0, so say I use negative 10. I'll use negative 1. That'll be negative, positive, negative. And two negatives together make positive. Okay, between 0 and 2, I'm going to choose x equals 1. I'll have positive, positive, negative. And so that will be negative, right? Because 1 negative with 2 positives is going to be negative. And something bigger than 2, like, I don't know, 100. Positive, right? Just choose it big enough so that everything's going to be positive. So it's positive, 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 meaning it's positive. All right, so these critical points, I'm going to have to scoot that up. I guess you don't need to see my factoring work if you already saw it. So I'm going to say that x equals negative 2 is the location of a negative to positive decreasing to increasing, minimum. Y prime goes from negative to positive. Okay, if this was the free response section of my AP exam that was determining whether or not I got college credit for the course, I would use a little more words than this, but for now this will be fine. Okay, x equals 0 is the location of a maximum because the derivative went from positive to negative. This is a number line of values on y prime. Okay, so is the location of a maximum. Y prime went from positive to negative. Okay? And then x equals 2 will be the same as up above. It went from negative to positive, so I'm just going to copy this word, these words exactly. All right, I'm going to be happy. That'll be all. Right, for number 3, this one's a little more interesting. They're going to start us off with f prime. I kind of like that. All right, f prime equals x minus 3, x plus 2. This one, I feel like you gotta graph this one. That's the only way to go. Because this is equal to 0 at negative 2 and positive 3. That's going to make a parabola. It's going to open up because it would be positive x squared and some other stuff. So I'm going to go down like this and up that way. Okay, great. So the critical points are x equals 2, negative 2, and x equals 3. And so maybe I can go over here and do it off to the side so I can save some space. X equals negative 2 is the location of a relative maximum because f prime changed from positive to negative. Okay, and then x equals 3 is a minimum because f prime went from negative to positive. Okay. Let's see. Oh, that's some serious factoring here on the next one. But, okay, having worked all of the homework problems alongside y'all this year, I can say that this is the first time that group and factor has shown up. And while that is certainly probably not something you're going to see, certainly probably, on the AP exam, I don't think I know of any College Board items that use group and factor. It is certainly the type of thing that they would expect you to do in a college calculus class. So if we have number 4, f prime equaling x to the 5, 2x to the 4, negative 25x to the 3, and negative 50x to the 2, if we've got that parallelism, that 1 to 2 is the same as negative 25 to negative 50, that's kind of the end. And with descending powers, you know, just descending nicely, that's the pattern that we can use group and factor on. So that's going to be, take the first two things, wait, I can factor out an x to the 2 out of all of these. But then after that, I'll have an x to the 3 and 2x to the 2, so I'll be able to take out an x to the 2 times x plus 2. And then I'll have a negative 25 in common to these things, because after I've taken out the x squared, I'd have negative 25x minus 50. And I'll be left with an x plus 2. Whoops. And I need another set of bracket there. Cool. So now I'm pretty much ready to factor this thing, because this will be x squared times x plus 2, and I'm left with x squared minus 25, which is x plus 5 and x minus 5. Some good old-fashioned factoring here. Okay, so this is a big one. I'm going to have negative 5, negative 2, 0, and 5. Right, and I do not draw these things to, there's no need to. Yeah, you could use test points if you wanted to, but I'm thinking this is a second, third, fourth, what did I just do? Hold up. Oh, yeah, this is f prime. Okay, so f prime is a 5th degree polynomial with a positive leading coefficient, meaning that much like x or x to the 3rd, it comes from below and then eventually goes up. So I'm going to start from below. I'm going to pass through confidently at negative 5, because there's only one power here. Confidently at negative 2, only one power here. It's going to bounce at 0 because of the even multiplicity. And then it's going to pass through confidently at 5. So I'm going to, just for the sake of time, because you saw me write out the explanations, you know, my justifications in words, some better than others, I am going to go over here, and I'm going to say that this is a relative minimum. This is the location of a relative minimum on the graph of f. How about that? Over here, this is the location of a relative maximum on the graph of f. This is neither, because there was no sign change. And then over here, f prime went from negative to positive, meaning we had a minimum. Okay, that's number 4. That was a lot of that. But that's kind of to be expected at this point in the introductory calculus course. Now we're going to determine the intervals over which the function is increasing or decreasing. Yeah, sure. I'm not sure if that's grammatically appropriate. I have to think about that. Okay, so number 5. G equals 4x e to the negative x divided by 2. Oh, y'all were telling me y'all need work on chain rule problems like this, with the exponentials. I know that y'all are this year feeling like you need more support there. So here we are, we're doing it. So we need to, in order to determine increasing, decreasing, we need to take the first derivative and determine where it's positive and negative. So G prime is equal to 4e to the negative x divided by 2 plus 4x times the derivative of e to the negative x over 2, which is going to be e to the negative x divided by 2 multiplied by the negative 1/2 for the chain rule. Okay? And it's plus, right? This is a product here, 4x times e to the negative x over 2. And so I will say, I'm gonna do some serious factoring here, right? Because I'm going to factor out the e to the negative x divided by 2, and I'll be left with a 4, basically minus 2x. Now, this is the type of thing, e to the negative x divided by 2, no matter what x is, this is always positive. So that's not going to give us any zeros of our derivative. It's not going to give us any other type of critical points either, because e to the next x divided by 2 is always well defined. Okay, so I don't have to worry about g prime d and e. Okay, only g prime equals 0, and that's only at x equals 2. Right? And so that'll be over here at 2. And so what I'm going to do is I'm going to choose a number less than 2, and I'm going to choose a number greater than 2, and I'm going to use those test points to determine whether or not g prime is positive or negative on its respective interval. That's g prime. So choosing x equals 0, I'm going to have e to the 0 is e to the negative 0 is e to the 0 is 1, times 4 is positive, times positive is a positive number. Okay, over here, x bigger than 2 is going to be, I don't know, like 10. E to the negative 5 is a very small number, but it is still positive. And over here, 4 minus 2x, what's happening there? Oh, when x is 10, that's going to be very negative. So I'll have positive times negative is negative. Okay. So I'm going to say that this is the interval on which g is increasing. So negative infinity up to positive 2, because always use a reason. And your reason should always have to do with the sign of something. And that's something you'll hear me say more as time goes on. But I'm going to just say g prime is positive. And then I'll say g is decreasing for, maybe I'll say x greater than 2. And you don't have to write it as an interval. You can write it as an inequality. Because that is where g prime is less than 0. Right? Over here, it would determine it was negative. All right, and number 6, I'm going to have to use the quotient rule for, but I could probably keep using this sheet of paper. For number 6, I'm going to say g of x equals x squared divided by x minus 8. So while y'all did struggle a little bit on, exponentials and chain rule with other transcendental functions, y'all seem to be really solid on the Unit 2 test on quotient rule. I really think that we did good work there, so I don't think you're going to need too much support with this. Bottom, derivative of top, minus top, derivative of bottom, divided by bottom squared. Oh, and we've definitely taken the derivative of this type of thing a few times because there was a question on the quiz that dealt with this. But if I were to try to simplify, I'd have 2x squared minus 16x minus an x squared is 1x squared minus 16x divided by x minus 8 squared. Now, on the topic of critical points, this one's kind of interesting because the g prime will equal 0 at x equals 0, and also at x equals 16. But also we have g prime DNEing, not failing to exist at x equals 8. So those all need to go on my number line to test for critical points. And, I mean, unless you're just an expert at drawing the graph of rational functions, which I'm not, you're going to want to use the number line and test points for this. Okay, so something more negative than 0, like, I don't know, negative 100, might actually be useful to factor this also. Okay, yeah, much easier to have it factored when you're plugging in like a large negative number, like negative 100, because I'll have negative times negative is a positive, divided by positive, it's going to be positive. Okay, 0 to 8, I'm going to choose 1, right? 1 minus 16 is negative 15, but then I take negative 7 and square it, I'll have negative divided by positive is negative. Here at 8, I think we're not going to have a sign change because of the double factor here, but I'm not totally sure. Let's choose 10. Okay, 100 minus 160 is going to be negative, or 10 times negative 6 is also going to be negative. But then I take that and it's going to be positive, so I'll have negative divided by positive again. And something bigger than 16, I don't know, maybe 1,000. Huge. Positive, positive, positive denominator, it's just all positive. Okay. And we don't have to be too fine with our explanation here. I'm going to say G is increasing for x less than 0 and, x greater than 16 because G prime is greater than or maybe equals 0 or undefined. If you just say G prime is positive, they aren't going to mess with you on that 8 right here where G prime is undefined. We don't have to worry about that. G is going to be decreasing between 0 and 16. Okay, and you can make those less than or equal to if you want. It just depends on your definition of increasing and decreasing, right? Okay, so that's the first page. All right, this I think I'll be able to fit on. Okay, this is the graph of the derivative of f, not the graph of f. Okay. You'll find that on the quizzes and stuff, I think at first I give you that type of information really explicit. I underline the not the graph of f, but time's going to go on and you're going to have to recognize that you're looking at the graph of the derivative and that you need to act accordingly. Starting by listing the critical points of f. Okay, that's going to be where f prime is 0 or undefined. I don't see any place where where f prime is undefined, so it's negative 7, 1, 4, and 8. And then we'll have, where is f increasing? Pardon me. We know how to do that because, well, we know where the derivative is positive, right? We're just going to be looking at it, I think. And, no, that should be 18 enough. And so, okay, I'm thinking f prime is positive. That's in here, negative 7 to negative, but also 4 to 8. Where f is decreasing is just everywhere else besides this, right? But x is less than negative 7. Here where it's negative 1 to 4. But then also bigger than 8 is also where f prime is negative. And, you know, I didn't ask for a reason, but it's always good to give a reason. So I'm going to say f prime is positive. Over here, f prime is negative. Here, f prime equals 0 or fails to exist, right? At what values of x, if any, does f have a local maximum? Okay, at this point, all we know about a local maximum is that's where f prime goes from positive to negative, right? Because the function went from increasing to decreasing. So I'm seeing here at x equals negative 1. Oh, and there's also one hidden by my face over here at x equals 8. And that will be, those will be the x values at which f has a relative maximum. All right, and at what x values, if any, does f have a local minimum? Well, that'll just be where f prime goes from negative to positive. Right? And so that looks like it's happening here and there at 4. Whoops. X equals 4. Okay, and that'll be all for that one. Okay, that went much quicker. Oh, right. List the critical points of f and g. Critical points of f are going to be x equals, here, negative 1. X equals 0 because the derivative is 0. I'm looking on this row right here, f prime, anywhere where I see 0 or d and e. So it's going to be this one as well, -1, 0, 1. And for G prime, I'm going to look, well, really, I guess I'm not talking about the critical points of G prime, I'm talking about the critical points of G. So I'm going to look in the table in the row for G prime, and I'm saying, okay, here we go, I found one. And that's just x equals 0. Okay. Relative extremum, okay, that is where we have a sign change. It's a maximum or a minimum. So that's going to be any type of sign change on f prime or G prime. All right. So for f's extrema, that will be over here, negative to negative. That is not a sign change, but negative to positive is indeed a sign change. So 0, 0. I might say, I think you know that if the derivative goes from negative to positive, that's a minimum. But it didn't really ask you to classify them, but I'm just going to point that out. Okay, and then was there there's another sign change in f prime over here. It's going to be a sharp corner most likely, but that is going to be, especially because f of 1 is well defined. Let me think about that. Pretty sure that guarantees. What if there was a jump discontinuity? Okay, I would have to think about that more. For now, I would say I wouldn't lead you into a situation where it's like, oh, gotcha, there could be a jump discontinuity. You don't have to worry about that. Let's say positive to negative is 1, 4. That's going to be a maximum. I'm just going to assume that was a sharp corner. I feel like there could actually be a jump discontinuity there, where f was defined but f prime wasn't. I don't know. Don't want to think about it too hard. Don't want to waste your time. Okay, G's extrema, we're looking for sign change on, here it is. Yep, positive, 0, negative. All right, and so that would be at the point 0, 3, we have a maximum on G. Okay, that'll be all for that set of problems. All right. The graph of f prime is shown how many critical points, how many extrema. All right, a critical point is f prime equals 0 or f prime fails to exist. Is f prime changes signs. Okay, so f prime equaling 0, that's 1, 2, 3, 4 times. Sign change, this is not a sign change. I went from negative to 0 to negative, so I didn't change my sign. It's just going to be 3. So here's a relative minimum. There's the location of a relative maximum on f, on the original f. And then that's the location of a relative minimum on f. All right, so I'll say 3 extrema. Just in case you were interested in knowing, that's, what is it going to be? 1 maximum and 2 minima. All right. And okay, find the value of x that satisfies the conclusion of the mean value theorem applied to the differentiable function g of x on the closed interval 0 to 2. Okay, the mean value theorem, the deal with that is that average rate of change equals instantaneous rate of change. So I need to compute, really it's g prime of x equals g of 2 minus g of 0 divided by 2 minus 0. And we're going to solve for the x's that makes that true. So I'm going to need to take g prime, and I'm going to need to take this difference quotient. So when I plug in 2, I'm going to get pi minus sine of pi is 0. So that's 2. No, pardon me, that's pi. Pi divided by 2 times 2 is pi. Minus g of 0 is looking, well, sine of 0 is 0. Okay, so 0 minus 0 is 0. So that's equal to pi divided by 2. Okay, so I want to find where's the derivative equal to pi over 2, and we will be able to do that because g prime of x is equal to the derivative of a number times x is just that number. So minus, use the chain rule, that'll be pi over 2 cosine of pi over 2x. Okay, now I'm going to, I'm going to say, hey, where does that equal pi over 2? Well, if that's equal to pi over 2, then the pi over 2 came from here, right? So I'm going to need this cosine to equal 0. So cosine of pi over 2x. Okay, I mean, you could definitely subtract pi over 2 from both sides, and you'd say it equaled 0, and then divide by negative pi over 2 to say that that cosine needed to equal 0. Or you could just look at it. And wait a second, I know where cosine is equal to 0. It's here and there, right? And as far as x, well, that's pi over 2 and 3 pi over 2, so that's x equaling 1, because that makes me take the cosine of pi over 2. And x equals 3 pi over 2, well, I need x to be 3/2 in order to take the cosine of 3 pi over 2. Okay, so these are two values of x that satisfy the conclusion of the mean value theorem applied to the differentiable function g on the closed interval 0 to 2, right? Because both of those are between 0 and 2. Okay, so that's interesting. Right. And then some position, velocity, acceleration. Okay, find v of t, the velocity of the particle. Okay, v equals x prime, which is going to be 1 plus 2 cosine of 2t, right? Just chain rule, derivative of the outside is cosine, leave the inside the same, multiply by the derivative of the inside, so I get that 2. All right, well, I found the velocity. A of t, a equals x double prime, which is, I could just take the derivative of this, and that will be good. That'll be 0. Minus 2 sine of 2t multiplied by 2 for the chain rule is negative 4 sine of 2t. Find the values of t where the particle changes direction. Notice that the domain is restricted to 0 to pi, so I'm going to keep that in mind. All right, so we want to know particle changes direction. That's where v changes signs. All right. And so I'm going to just say, well, where does v change signs? Well, 1 plus 2 cosine 2t. Okay, I'm going to find where it equals 0, and hopefully that'll help me. Okay, so that means that that cosine has to equal negative 1 divided by 2. Okay, where is cosine equal to negative 1/2? That would be over here, where that's the short leg of a 30, 60, 90 triangle here. I suppose this one would also work. Okay, still negative 1/2. So that means that t is going to be, this is 2 pi over 3, and that's 2t is going to be 2 pi over 3, and 2t is going to be 4 pi over 3. Oops. All right. I don't know why I was freezing up on that, the last step of the last problem. That's going to be t is pi divided by 3, and t is 2 pi divided by 3. Okay, these are the zeros. The question is it reasonably changing direction? And it is. You know, with trig, we know that the zeros are kind of zeros. But let me see if I can draw a picture of this for you, and like, you know, give you reason to believe me on this. All right, let's see. After 2 pi over 3, okay, cosine goes more negative than negative 1/2, right? So we go from being, cosine is, you know, 0 over here, and 2 cosine of 2t, yeah, you're gonna have to just believe me that it's a sign change. I could have gone a completely different direction, and, you know, if you're done with this problem, you're done with this video, feel free to, you know, just X out the window, right? But I feel like I should give a little more. I'm going to draw a picture of 1 plus 2 cosine 2t, because I know what the graph of cosine looks like, and kind of looks like that. And that's going to be at least one period of it. Because it's 2t, this is going to be pi, and that's going to be 0. It's going to be 1 plus 2, because cosine of 0 is 1, that'll be 3. And the depth is 2, or the amplitude, that's what we called it. And so that's 1, and then that's negative 1. So I've got this 0, this x-axis there, so I know I'm going to have a sign change at each of the places where it's equal to 0. And I did find 2 of them, so that's a good sign. You know, I think that's going to be all for this video. Thanks for watching.